Hi, this time we get to the long question. Although we know that when it's on the real exam, you do not write on the paper. So make sure you have all your answer from the long question, from the section B long question will be on the sheet, on the paper provided. However, I'm going to write it here because I'm just running out of space. Actually, I can write it, I only can write it on paper. So let's do it. I got my paper here. And I got my calculator here. I got everything. By the way, just people, I think the followers will know that I'm using the Casio FXCG50 for the exam here. Just personally, I like it. And my school is using it. Okay, so let's get started. The temperature of a cup of tea after tea-minute poll is modeled like this. And the temperature should be decreasing. So first of all, in my practice, I write down whatever I have first. All right, calculator, I'm going to wait for now. E negative 0.08 T. And then we need the initial temperature. So initial temperature means that when T equals to 0 with the start of it. So especially there's the domain here, so the start of it. So we pretty quickly, we use 0 there, 1A1. So we have 21 plus 75e to the power 0. That gives us 21 minus 75, plus 75. That equals to 96 degrees. Pretty straightforward, substitute a 0 in, easy, 1 mark from there. All right, find the temperature after 3 minutes, so means that H3. So I'll use my GDC this time. 21 plus 75 E, shift N. The E is here, so shift LN. Oh, do I see everything? I wish we got bigger screen. All right, and we plot it out. So minus 0.08 times 3. So it should be 7.79. We're using GDC here, so it's 79.997, blah, 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 whatever. We take 3 sig fig. So make sure it's 3 significant figure only. We need to have the 0 there. If you miss that, you miss it. Oh, write down the value of H-3. You can do it by hand. So we will have 75. We can differentiate first. So we will have 21 is gone, 75 times negative 0.08 e to the power negative 0.08 t. Or you can actually get to your calculator, you take that out. One of the way is you go to our normal calculation. We go to option, not here, cal. So we got your first differentiation. The calculator will be able to give you the first differentiation there. So F-3. So we key in our equation. 21 plus 75 e to the power negative 0.08 times x. And then when x equals to 3, you got the answer, which is negative 4.7197. So it's negative 4.72. When I use a calculation, I will use the full value when I need to. Alright, and then interpret the meaning of part B in the context. So, which means the rate of change there. So, there is 2 marks there, so it's like a 3 there. So it's the rate of change. I hope I can see both of them. Can I extend the screen a bit more? Does it work like this? Oh no, that's the best I can do. So, rate of change, because it's differentiation, at t equals to negative 3. So, when t equals to 3, which is the 3rd minute, we could have the temperature changed at 4.72 degree per minute. So I have the rate of change information. T is when at T equals to 3, that's the third minute, the temperature change is 4.72 per minute. So that's how we getting those, getting the information there and to get the 2 points. Right? 好啦 Next bit. We're getting pretty Cantonese here. Okay, so after K minutes, let me do a sideway that we'll see easily. After K minutes, the temperature below 67 degree and is ready to drink. For find the value of K. So we want the temperature there. So HK equals to 67 degree. So we can use our graph, our GDC there. Yeah, this time I really have to graph it. So that's the previous stuff. So we have 21 plus 75 e to the power negative 0.08x. You lost it. So first of all, we auto zoom it because auto zoom allowed us to see the vertical. They auto the range. And then we just double check with the temperature at the scale. So minimum, it's 21 degree, pretty cold. And then the maximum is that. So we will have 50 minutes. So it should work pretty. Now we got that. We got K. So G solve. This time we want X. So X scale when Y equals to 67. They should give you the information is 6.11 minute. 6.1105. But here we got when the T is what is the least possible value when K is an integer. So be careful, devil's in the detail. K have to be an integer. So at least the 7 minute, the tea will be ready to drink. That's long. Oh, next bit. We got 2 more. As the T cools, HT approach to a room temperature, which is a constant, which means that if I have the graph, yes, I have the graph, we are looking for the asymptote. Because after a certain temperature, it won't drop anymore. So which means that pretty straightforward. I know that E, room temperature, is 21 degree because this allowed us to be an asymptote. How do we find it? Because we know E usually is like start from 0, a decay, tends to 0. Now it's translate 21 upwards. Or you really forgot how to find the asymptote of it. So you can go to trace. And then you keep moving it and focus on the Y value there. If you keep going on, it's keep going to getting closer and closer to 21. It's a bit dumb, but then it's keep closing to 21, but never get through 21. So you can assume that it's an asymptote. The method is not ideal, but it might come in handy when we need them. F. Find the limit of H when it tends to 0. When H tends to infinity. So T, the temperature tends to infinity. So we have the change equals to, we need the rate of change. So we have the limit when T tends to infinity. What will H dash T do? So this is what we're going to do, and I am pretty lazy. I am going to differentiate the HT again. Where's my H? I have my H differentiator before. Ta-da! So this is the H when 75 times negative 0.08 E tends to infinity. Alright, so when 8 tends to infinity, which means that we will get to, for the limit, T tends to infinity, we will have 75. Just do the math. The 0.08 is a bit annoying. 75 times 0.08. Oh, God, it's 6. Alright, it's 6. 6 times e to the power negative 0.08 infinity. Yeah, we can just tend to there. And then, because it's negative number, so again we have, I don't want to see this, I want to see this, 6e negative 0.8 x. Again, I lost the graph, so I have to auto zoom in again. There we go. Now, when you look at the graph, you know that it tends to 0. So, just in case we trace it, so if it's just getting closer and closer to 0, never get to the 0 there. So, which means that the x is getting smaller and smaller, but not. So, that is the asymptote of it. And this is another 2 marks. This question is a bit, I do not think it's hard, but it's a bit tricky, especially that you need the concept of the differentiation and very strong thinking knowledge in the exponential function. So until next time, we will have another long question for you. See you.